Okay, this lesson is on section 2.1, graphing absolute value functions. So today we're just going to take a look at two specific functions. We're going to graph it a bunch of different times with respect to a limited domain, and then we're going to figure out what the range is based on that limited domain. So we're going to practice these really important skills here. Objective one is just to make sure you know how to graph a function with a table of values. So that means, setting up your x, y, and then based off of the points that you're picking, being able to plot that. You're also going to graph then within a restricted domain, like I said, and then be able to identify the range within that restricted domain. Okay, so the first example here is a little bit more complex of an absolute value graph than we've been doing in the past. So we're only focusing on absolute value graphs here. So the first thing I want to do is create an XY table. Now if I select my normal -2 to 2 here, I might not get a very good idea of what the picture of this graph is going to look like. So I'm going to try to pick some values around, basically some smarter values. Like I'm going to start with the number 4 because remember we want to make that inside of this be 0. So I'm going to pick the number 4 to start, and I'm going to pick values around 4, meaning something smaller than 4, something larger than 4, and then some additional points beyond that. Okay, so if I plug in 2 into my function here, I get the absolute value of -2 plus 1, and that is going to equal 3. So I'm going to plot the point 2, 3, and you guys can go ahead and pause it if you want and fill out this table. I'm going to go ahead and fill out the table. Okay, so here are my table values now, and I'm just going to go ahead and plot those points. So I already have 2, 3 plotted. I'm going to plot 3, 2, 4, 1, 5, 2, and 6, 3. Okay, so already I'm kind of getting that V shape that we know that we should expect when graphing an absolute value function. We can also see from our table, if you look at this point here, all the other points around this point start to bounce off of it. So you can see these values starting to increase here, and these values here were technically decreasing once they hit 1, but you can kind of see the difference here in the table, and that's why your graph is going to look like this. Even if I increase the values here, I'm going to get 1 larger, so I should get 7, 4 the next time I plug in. If I were to decrease and plug in 1 here, I would get 1 larger here as well, so I would get 1, 4. Alright, now the graph here, if we think about it with respect to our window, and this is the ceiling, ceiling and floor, our graph goes through the ceiling, right? If we were to extend this forever, it's going to go through the ceiling. It does not go through the floor. So it's not, in this case, a range of all reals. So we want to think about what our lowest point is on this graph. The lowest point is right here at y equals 1, and it extends forever, right, to positive infinity. So this is going to be y is greater than or equal to 1. On every point on this graph, y is greater than or equal to 1. Alright, now this is where we start getting a little bit more difficult here because we're going to restrict our domain. So this time we're only graphing when x is greater than 3. So it's the exact same function, but now only when x is greater than 3. So you got to think about that on your graph, what that would look like. So what you would want to do first is go to where x is 3, and you're basically cutting off the rest of this side of this graph. You don't want any of that graph anymore. All you're really looking at is this part of your function. Okay, so normally you're not going to be able to graph just right away. Like, we're not going to give you 4 of the same picture, and asking you to graph it 4 different times. We might just give you this and ask you to go straight to this domain. So you want to be able to plug into the table as well. So what you would do is you would start, your starting point here is 3, right? They're asking you to graph when x is 3. So at 3, I already know it's going to equal 2 because I already filled out my table before. So I'm just going to steal that value. I'm going to graph 3, 2. And when I graph that, I want to make sure I have an open circle there because of this sign, right? It's not actually equal to 3. So it's just greater than 3, so that's going to have just an open circle on x equals 3. Okay, so now I want to continue to pick values that are larger than 3, like 4, 5, 6, and again I'm just going to steal these table values over here, so that's going to be 1, 2, 3, so 4, 1 is here, 5, 2 is here, 6, 3 is here, and now I still have that V shape, but it's going to continue forever as I increase my x values, right? As I increase my x values here, this range is going to increase as well. So this is what the picture should look like. Remember, you're cutting off the rest of this. This is no longer within your domain, so you're not graphing that portion anymore. Now, to find the range, again, you go to the low point. The low point on this graph is still y is equal to 1. So we have y is greater than or equal to 1 because, again, as x increases, the range also increases to positive infinity, right? It goes through our ceiling up here. So y is greater than or equal to 1. Okay, now part C here says our domain is now non-negative reals, so we need to figure out what non-negative reals mean. So this is positive numbers, but it also includes the number 0, right? So this is positive reals along with the number 0. So when I make my table, I want to include 0 and any other positive reals that I want to include here. And again, it's probably easiest to use all whole numbers. So I'm going to go ahead and fill out this table. Okay, so there's my table. Just make sure that you guys are really careful with your order of operations here. You don't want to make a mistake in creating this table because then you're going to get really confused when you try to graph, because your picture's not going to really make sense. Especially, like if you know it's an absolute value graph and you get something that looks like this, that means you've obviously done something wrong. So make sure you're going back and checking your table of values. Okay, so I'm going to plot that real quick. 0, 5. 1, 4, 2, 3, 3, 2, 4, 1, and then remember this is where it kind of bounced off before, so I would probably want to do a couple more just so that I can verify that it bounces back up here. And this is what our graph would look like. Now, I didn't really mention this right away when I graphed this point, but I did put a closed circle here because, again, in the domain, 0 is part of a non-negative real, so I do want to have a closed circle on 0. Okay, so when I graph this, I'm going to connect all of these points. Let me erase a little bit here to get some more room. And if I were to keep going with my table, I would still continue to get more value, so this is going to go to positive infinity as well. Now, I'm not graphing anything beyond this 0 here. Notice I'm not putting an arrow like this here because this is where my graph is supposed to start. This is where non-negative reals start. So again, I want to find for my range a low point and a high point. So our low point here is at 1, y equals 1 again. Our high point, since this is going to keep going, continue forever through our ceiling, there is no maximum because it goes to positive infinity, so y is greater than or equal to 1. Now in problem D here, the domain is changing a little bit, right? Now they're giving us a range of numbers. X is supposed to fall in between -2 and 8. So when we select our points, we only want to select points between -2 and 8. So I'm just going to kind of skip a few values, but I only want these points, any numbers that fit between -2 and 8 are the only numbers that I want to choose. Okay, so I'm going to go ahead now again and fill out that table. Okay, so I went ahead and I actually plotted those points that I got from my table here. Notice I did skip some values between 4 and 8, so that's why I'm missing some points in between here, but I could always plug in numbers because 5 falls within this domain, so I could plug in a number here and I could find that this is my additional point. So I do know that there are additional points on this graph. I just didn't mark all of them. So I'm going to connect it with a solid line to show that these are all part of my range. Now, when doing your range here, it's a little bit trickier. So you want to find again the low point. Low point happens to be y equals 1 again. The high point though is actually here. And notice that I graphed this circle as an open circle because in my domain it said -2 is less than x, which means that x doesn't actually equal -2. Okay, so x is basically greater than -2, which is why I have an open circle here. Okay, not equal to -2, it's greater than -2. So when I do my range, this value, the 7, right, this is where y is 7, is actually not part of the range either because the function here doesn't actually equal 7. It's just beyond that point that it's part of our range. So when we graph this, we're going to do our low number first. 1 is less than or equal to y, right, because it's actually equal here, and then is less than 7. So that's how we write our our range for this problem. Okay, the last one is the easiest one here because you're only given 3 points within this domain. Okay, there's distinct 3 points, which means when you graph this, you can only use -4, -1, and 5 in your table. Okay, so we plug that back into our function. We would get 9, 5, 6, and 2. So I'm going to plot the points -4, 9, -1, 6, and 5, 2. Okay, so there's your y values, your x, y values plotted here. Notice that I didn't draw anything to connect these points, right? This is implying when you connect these points, this is implying that this is part of your range, and these are not values that are part of your range because we're only restricted within these specific table values. So when you write your range here, you only have 3 numbers, and those are these values here in the y. So 2, 6, and 9 are your possible y values within your range. Okay, I'd like you guys to try problem number 2 here. It's the same format that we just did before with example 1. We're taking the same function and we're going to plot it with respect to a limited domain in 5 different graphs. So I'd like you guys to try A through E and then pause the video, see how you did, then play it back now so that you can kind of hear the explanation if you don't get the answers right. So check with the key first. If you get everything correct, awesome, move on. If not, then continue with this video tutorial, okay? Okay, when I select points to put into my function here, I'm going to select points that will make this be equal to 0. So I'm going to start at -1. I know that's kind of where I want to build off from, and I'm going to increase values around that, and I'm also going to decrease in values around that. So I'm going to start with this table and see what my function ends up looking like. Okay, so I went ahead and I filled out the table. I'm just going to do this last value with you guys so you can see where it's coming from, just in case you're not getting the same numbers. So we want to plug in right back into our function, and order of operations is really, really important here, so make sure you're doing that correctly. So this -2 is going to stay out of the way for a second before I evaluate the inside of that absolute value. So I have -2 times the absolute value of 2 plus 4. So I have -2 times the absolute value of 2 is still 2. So that gives me -4 plus 4, which is why I get 0. Okay, so let me erase all this and plot these points now. Okay, so here are my plotted points, and I am getting a V shape. It's just now an upside down V shape. So if I were to keep decreasing in x values, and these are decreasing, right, because we're going to the left on the x-axis, I would get a shape that looks like this. And if I kept increasing in my table values, so in other words, if I put 2 in and 3 in, I would get this kind of shape here, okay? All right, so this is with respect to all reals, what my domain, or what my graph looks like with the domain of all reals. So let's try to figure out the range really quick. So for the range, we want to find the low point and the high point. In this case, this is going through our floor. This is going to extend to negative infinity, so we really have a high point in this graph and no actual low point. So when we look at the high point here, this is going to equal 4, right? This is where y is equal to 4. So that means that the range is less than or equal to that number 4, right? Every point on this graph is less than or equal to the number 4. Okay, now with respect to x is less than 5, I want to kind of come back over to our old graph here and look at where x is 5. So 1, 2, 3, 4, 5, and this point somewhere, I didn't really graph it accurately, but somewhere beyond here is where we're trying to graph. We only want to look at values that are less than 5, so that means this part of our function, these values are all less than 5. Nothing over on this side is less than 5, right? Beyond when like x equals 6, we don't want that on our graph. So that's what I'm going to do. I'm going to start plotting some table values, and I'm just going to steal these same table values because I picked numbers that were all less than 5. Okay, so I'm going to plot the exact same looking function. So I'm going to pause it real quick. Okay, so I went ahead, I plotted the exact same table values here that we already found, and I actually had to go and find when x was 5 and 4 as well, so you can see where I plotted those points here. Now, I put an open circle on 5 because these values are supposed to be less than 5, okay? So I should mention too that, like I said, you're not going to be given multiple graphs. You're just probably going to be given this problem and asked to go straight away to this domain. So you won't get a chance to compare to, you know, the original function and what it looks like when you're graphing any real number. So when you're asked to do it with respect to 5, you want to start at 5 and then go from there. Since these values are supposed to be smaller than 5, you just continue to make and choose points that are smaller than 5. So this is what my table should have looked like, and then obviously filled in here. So when I graph this, I do connect everything here. This is going to keep going. I just don't have more points plotted, but this does keep continuing to go because these values here are all where x is less than 5 as well. So this does fall within our domain, which means that these points here are also within our range. Okay, so when we decide to do our range, we want to figure out a low and a high point. Now, this is kind of confusing because this graph does keep extending beyond this point. This is not a low point. Okay? This graph does go to negative infinity. The farther and farther we go down, the more and more, that number will decrease. So it keeps going to negative infinity. And we have a high point here. Okay? And our range actually happens to be the exact same range as before. We have all possible values that are less than or equal to 4 again. Okay? So it's the same range that we had before. Even though we do have a slightly different graph, it still has the exact same range. Now, in D, it asks for only positive reals. So positive reals are numbers not including 0, but you still want to start with the number 0 because a lot of people forget that. They say, oh, 0 isn't a positive, so I shouldn't include it. Well, 0.000001 is, so if you start at 1, you're forgetting about all of these values in between 0 and 1. So you want to still start at 0. You're just going to have an opened circle on 0. Okay, so I'm again going to steal those values from up here because I've already done that work. Okay, so here I went and filled out the rest of that XY table. So this I'm going to fill in and connect all these points. Now notice I am putting an arrow here because if I were to continue to increase values, I would still get Y outputs, so that means that it's going to look, it's going to keep extending. When I do my range here, so this is the rest of the graph, this is all that it's going to look like, so notice it doesn't really look like a V, it just sort of looks like part of a line. When you do your range here, you still want to find a low point and a high point. The low point, there isn't one because it goes to negative infinity. It has a high point. This high point is at Y equals 2, but it's not technically part of our range, so that when we write our range, we're going to write Y is less than 2. All these values here are all less than 2. Okay, next problem. Here we are again graphing within a range from -4 to 3. When I pick my table values here, I only want to pick numbers that fall between -4 and +3. So you can skip around and just do a few points, but you probably want to, just for the start of it, just plug in as many points as you can in between -4 and 3. So go ahead and fill out this table. Okay, so I want to show you guys kind of here a problem with the table values that I had decided to select. So if I go ahead and I plot these, -4, -2, -2, 2, 0, 2, oops, 0, 2, 2, -2, and 3, 4, oops, I made a mistake on that, it's at -4, so 3, -4, okay, so it actually looks really messed up. I'm like, oh, am I supposed to connect it like this? Notice that you kind of have values that look like they're going to form a V shape, so you really need to figure out where that point is. So that's why you probably don't want to skip values until you're really good at this. So I need to at least plug in 1 here. Remember, 1 is what would make this inside, or -1, I'm sorry. -1 is what would make the inside of this equal to 0, so that's where I'm going to find where my V is. So I plug in -1, and I get +4 here. So 1, 2, 3, 4. Now I have a better V shape. Okay, so I also made a mistake here when I graphed this last point here. Hopefully you guys graphed that with an open circle, because again, when you go back to your domain here, x is not supposed to actually equal 3, so it should be an open circle here. So when I connect these points, I'm only going to connect within this range from x is -4 to x is 3. Okay, so I don't continue, I don't show like an arrow here. This would be wrong because it's only within that limited domain. When I find the range here, I have a low point. The low point is down here, the high point is up here. So I'm going to have to write it within a range as well. So y is going to fall in between our smallest point, which is at -4, and our largest point, which is at +4. Right, that was where our high point is. And I want to make sure I have the correct sign, so this is just going to be a less than symbol, so -4 is less than y. which is less than or equal to 4. Because this is a closed circle, this one here was an open circle. Okay, last problem here. Again, easiest problem because it just has you graphing these specific values. So I'm going to make a table here and only include these values. And I'm going to find those table values. Okay, so I just went ahead and I filled out the table. I also plotted those points, okay? In this case, I am not going to connect these values because, again, these are distinct points. X is only equaling these particular numbers, not the numbers in between. Sometimes you might see this with a dotted line to show that these are not part of the range in this function. You don't have to include that, but you might want to, just so that you continue to see that V shape. The range here then, because we're only including these values, means that we're only going to include these y values here, okay? So we would write that, I like to write smallest to largest, so -10 should come first, then -6, then 0, and 4. These are the only points, these y values here, that are included within our range when we have this particular domain.